Hello. Welcome to the last session of the last day of build. Sure, clap. I know you guys have spent the last 3 days just sucking in all kinds of new information about Windows 10. On behalf of the Direct2D and DirectWrite teams, I want to thank you all for coming here. My name's Anthony Hodgson. I'm a software developer on the Direct2D team. And today I'm going to be talking about some new features that we've been adding to Direct2D and DirectWrite in Windows 10. So let's go ahead and get started. Well, you know the drill. Please do evaluate after the session and give us your feedback. I'd really appreciate it. Thanks. In terms of an agenda, well, we're going to spend a few moments just talking about what Direct2D and DirectWrite are. And then we're going to delve into all the various enhancements that we've been making in various feature areas. So what are Direct2D and DirectWrite? Well, Direct2D is Windows' hardware-accelerated 2D rendering engine. It's responsible, whoops, go back here. Go forward. There we go. It's responsible for things like geometries and bitmaps, brushes, text. It also has support for image effects, so you can do things like blurs or sharpens or various creative effects. Now, DirectWrite is all about text. So it's used for things like loading of fonts, doing text layout, and typography. Now, both Direct2D and DirectWrite are foundational components of the OS. They're used widely throughout Windows. So for instance, it's used by the shell and DWM. It also drives a lot of the rendering inside of XAML. So if you're a XAML developer, well, you're actually already taking advantage of the hardware acceleration that, that DirectX provides for you. Now, if you take it a step further and you go ahead and use one of our new APIs, Win2D, well, then you're also taking advantage of the hardware acceleration of Direct2D and also taking advantage of DirectWrite. Now, incidentally, if you didn't get a chance to check out my colleague Simon Tao's talk on Win2D, I highly encourage you to go online and check it out. It's some really great stuff. Now, let's say that you're a web developer. Well, then a lot of your users are also taking advantage of DirectX through both the old and the new web browsers inside of Windows. It's also used by third-party web browsers like Firefox. So you get the idea. These are two components that are used very widely. But let's say that you're a DirectX developer, and I hope a lot of you folks out there are. What has Direct2D and DirectWrite got for you? Well, in Windows 10, we've been making a number of enhancements that we hope you can add to your applications and improve your experience for your users. So let's jump right in and take a look at some of these. So first up, let's take a look at some optimizations that we've been making to text rendering. Now, Windows 8.1, sort of standard mechanism that you use to render text was actually bitmap-based. So what this meant was, for every glyph that would appear on the screen, it would actually get rasterized on the CPU, and then it would be uploaded to the GPU. Now, to accelerate the process, we actually employed a hardware Glyph Cache. Now, as long as the elements were actually being pulled from this Glyph Cache, you would get great performance. This happened most of the time. There were some scenarios, though, where you didn't get such a great performance. And this is what happens when you had, for instance, scaling text. Say you were doing a pinch-to-zoom operation. Well, in this case, you'd end up having to repeatedly, or we would end up having to repeatedly re-rasterize all these glyphs at all the various zoom levels to ensure that they remain crisp. So we're doing a lot of work on the CPU, a lot of uploading to the GPU. But it got worse because our font cache was only a fixed size, which means that it could fill up. and you could end up having to purge the contents, which meant that you got a lot of thrashing of your cache, which wasn't great for your app or any of the other apps that may have been running concurrently on the system. So this was really not a situation that was suitable for giving you a nice zooming experience. Now, this isn't actually a problem that was specific to DirectX or even Windows. This is really an industry-wide problem. And the industry had a mitigation for this problem, which was effectively just render all your contents once to a bitmap and then stretch that bitmap. And this obviously gave you fast performance because you're just rendering a single bitmap, but it meant that if you were zooming in, well, you get really blurry results. In Windows 10, we have a solution to this problem, which is a new hardware-accelerated vector text rendering algorithm. Now, truth to tell, we actually did have a vector-based algorithm that you could use in prior versions of Windows. But this was really mainly designed for large text, like titles, where there wasn't as much on the screen, so it really wasn't tuned for performance. In Windows 10, we've completely redone this algorithm. And crucially, we're now also employing the Glyph Cache. So the Glyph Cache can now store not just bitmap representations of your glyphs, but also vector representations of your glyphs. And these vectors are much more scale independent, which means that we can use the same Glyph Cache entry even as we're zooming in and out on your document. So this gives your users a much better experience when you're doing something like pinch to zoom. Whoops. Let's go ahead and take a look at this. Switch over to here. All right. Now you can see I've got a lot of text on the screen. And I'm going to start off with just sort of the standard approach of rendering everything into a bitmap and then just zooming that bitmap and see what we get. Well, it's not too surprising. You're getting a nice, smooth experience, but when you really zoom in, gosh, that looks blurry. You have to pick up your fingers in order for it to actually look sharp. Let's zoom back out again here. Let's check out, see what happens with the new vector scaling approach. Now you're still able to render this really large amount of text, but it's all happening super smooth, and it's always sharp. Like, I can really zoom in here, and you get nice, crisp edges, nice, round Beziers. So let's switch back here. What do you need to do in order to take advantage of something like this? Well, as I said before, this is actually an existing technique that we offered in previous versions of the OS. We've just added new optimizations. So you're going to use the same technique. You're going to create a custom rendering params, and you're going to specify a DWrite rendering mode outline. And then when you render it, well, you're just going to set that text rendering params and then draw your text the way that you normally would. You'll notice, though, that I have this check here, if animating. And that actually brings up an important point. Whoops. Which is that if all you're doing is just rendering static text, well, you're going to want to actually continue to use our more traditional bitmap-based rendering mode, because this is going to give you the absolute sharpest, best quality text. We're going to be able to employ things like font tinting to ensure that all your stems remain perfectly on pixel boundaries. When you're animating or zooming or something like that, though, then we encourage you to switch over and use the vector text rendering algorithm. The other thing that you should be aware of is that this optimization that we've added is for feature level 10 plus hardware. So if you're using a feature level 9 device, well, you can still use the you can still use the feature, you just won't get the optimization. So you may want to play around with it on your particular device, see whether or not the feature meets your needs. But in any case, we feel that this is a really great thing that you can easily add to your application and give it a much crisper feel. Let's take a moment and actually talk a little bit about fonts now. Now, in Windows 8.1, we had an API set that allowed you to target both the phone and the tablet and the PC. Now, this was a very consistent API, but APIs aren't the whole story. And we got feedback from users that said, hey, you know, it's great that I'm able to or from developers, that I'm able to use the same API on all these devices, but some things like fonts just aren't the same. There simply isn't enough space on something like a phone to store the ½ gigabyte of fonts that you get access to on a desktop PC. So in terms of the end user experience, you could spend an awful lot of time carefully crafting your document on a desktop PC using just the right font, and then you transfer it over to your phone and you'd view it and it would just look different. We'd end up having to use a different font under the covers. So it's just a little bit inconsistent. Well, Windows 10, we have a solution to this problem, which is downloadable fonts. Now, the way this works is that the font set has now been segregated into two types. We've got recommended fonts. These are fonts that are guaranteed to be available on any device that your app runs on. This is going to include common UI fonts, things like Sigma UI. It also includes common document fonts, things like Calibri or Times New Roman. Now, all the other fonts are now optional, which means that they may or may not be present on the device that your app happens to be running on. But if they're not present on disk, they're always available up in the cloud via Microsoft service. And furthermore, your app can now download these just in time while your app is running and display them. There's a couple of important features to this new feature. First of all, it's fully asynchronous, which means that DWrite will never block when you're accessing these fonts. It'll just hand you back a resource immediately. You can use that resource and stuff will render. It'll just use font fallback. When the font actually completes downloading in the background, well, then you can pick it up and you can start using the new font. The other thing to keep in mind is that this is employing a global font cache of all the fonts that get downloaded, which means that if you have multiple applications that are all using the same downloaded font, well, it doesn't have to be downloaded multiple times. We can just pull it from the cache. This also works if you shut down your application and start it back up. We can take advantage of that. One other thing that you should know is that you don't actually need DirectX in order to get this functionality. We've actually built it directly into XAML, which means that your XAML apps will get this, this feature completely for free. To prove this, I've actually got an application here. Let's switch it on over. Now, this is actually a fairly silly little application. It only has the ability to open 3 documents, but that's actually sufficient for our purposes. Oh, let me close this guy. And I'm also going to bring up here a view showing what's actually stored in the font cache. Now, you see that it already has one file pre-existing in the font cache. That's actually just a catalog file. It's sort of keeping track of various metadata about all the fonts that are available to you. Now, I've got 3 different documents here. Let's go ahead and check out the first one. Now, this first one is actually going to use a font that is resident on the system. And boom, as soon as I click on it, no surprise, the document shows up. And you'll see down at the bottom that the desired font is Cambria, while the rendered font that we're actually using, also Cambria. So that's not really terribly surprising. This next guy here is going to be much more interesting. This is actually going to be pulling live from the cloud, I hope, as long as the rain gods are with me, pulling down a font. But as soon as I click on it, it's still going to be rendering using a fallback font, and it will dynamically switch over. So let me go ahead and click on it. And you can see that the desired font is Jokerman, but right now we're just using Sega UI. And bam, you can see that it's now finished downloading. You can check it out and see in the font cache that, yes, we've got a new file here. And sweet. By the way, you can probably tell why this isn't one of the recommended fonts that you should be using. Now let's take a look at this last one. This last one here is actually kind of interesting because it's in a East Asian font. And East Asian fonts are notoriously large because they have to store all these different glyphs in them. And so they can be tens of megabytes in size, like 30 megabytes. Let's go ahead and see what happens when we click on this one. Well, you can see that we've already started the download of the third guy. And you can see, well, now we've switched over. So we're now actually using the Katai font. And the other thing to notice here is that we haven't actually downloaded the entirety of the font. And this is because we're able to say, hey, these glyphs all appear in a certain region. And so I don't actually need to download all the font. I can just download the portions of it that are necessary. This happens all under the covers, behind the scenes. You don't need to worry about it. Let me go ahead and close these guys, and let's switch back. So that's what you get if you're a XAML developer. How about if you're a Directx developer? How does this work for you? Well, if you've used previous versions of our API, you'll know that the first thing that you commonly do when you're going to access a font is you're going to use the get system font collection. You're going to continue to use that. We have a new overload here where you can now specify that you want to include the downloadable fonts. So this will give you a font collection. You can create a text format from this font collection, or basically any other API that you want. And DirectWrite will immediately return you that resource. And as I said, you can use it immediately, and stuff will render on the screen, but it won't actually use the new font until you call these new APIs here, which is the font download queue. Now, the way this works is you register a listener, which you implement yourself, which gives DWrite a chance to tell you when the document has, when the font is finished downloading, and it tells you, okay, now I can re-render my document. So you add your listener, you begin download, and then you'll get the callback later. So you may be thinking, hey, great, now I don't need to worry at all about fonts. I can always assume that I have access to everything. I can use them everywhere. Well, there are some places where we actually encourage you to continue to use the recommended fonts. For instance, when you're designing the UI of your application, you want to be sure and use recommended fonts. This will help ensure that you get a consistent experience even when your user is offline. It also means that if your user is online, but is using a phone, you're not actually taking money from that user via their data plan. So instead, we encourage you to use downloadable fonts to maintain document fidelity. So use it when a document is actually authored on a PC and transferred over to your phone. Still, we think that this will give you a much more consistent experience for your applications that are viewing documents. Let's talk about one more thing regarding fonts. Font collections. Now, you just saw we were using font collections with downloadable fonts. They're a highly structured mechanism for enumerating your fonts. You can basically do two things with them. One, you can walk through all the fonts that are available on your system, one by one, in some predetermined order. Or if you happen to know your family name, well, then you can use that family name to key off the particular font that you want. This worked great most of the time. We actually received feedback from a number of developers, though, that they actually found situations where they didn't know the family name. They knew something else, like they knew the postscript name. Well, we really didn't have a great story in previous versions of the OS. What they ended up having to do is enumerate all the fonts on their system just to find the one that they were interested in. And this ended up affecting performance, and it was just kind of a pain. So in Windows 10, we now are introducing font sets. These are a more flexible alternative to font collections, and they improve your life in a number of ways. Now, I should say that if you're happy using font collections today, you're not running into these problems, well, please go ahead and continue to use font collections. But we do feel that font sets will make your life easier in a few ways. For instance, as I mentioned before, with a font collection, you really have to key off of the family name. With font set, you can query off of any one of a number of different properties. You can key off of the family name, postscript name, even much more generic things, like you just want to see all the italic fonts that are available, or all the bold fonts that are available. You can do that. Also, for those of you who actually need to create your own custom font collections, let's say you've got a document with an embedded font. You could do this with font collections, but it's actually kind of a pain. You need to implement this callback interface, and there was some pinging and ponging that ended up happening between your app and DirectWrite. With font sets, this is a much simpler process. It's just a builder pattern where you do add font, add font, add font, and you're done. As I mentioned before, you could use font collections to do downloadable fonts. Well, you can do the same thing with font sets. Font sets also give you additional functionality, though, in that you can query metadata about fonts that aren't resident on your particular device. One other thing to know is that if you happen to have a font collection and you want to get a font set, it's really easy to just at any time switch over and you can get access to the other resource, or vice versa. How do you do this in code? Well, just like there is get system font collection, there's get system font set. And you can specify the properties that you're interested in. So in this case, I'm interested in finding fonts that support both italics and bold. And you can call get matching fonts, and it will give you back a new font set that contains only those guys. So that's just a nice little feature. You may need it, you may not. But moving on, I'd like to talk about image loading and rendering. Windows 8.1, we had a number of different APIs targeted at various scenarios that you could use to load your images, things like JPEGs, GIFs, PNGs, so on and so forth. And we got a lot of feedback from developers saying, hey, we really appreciate having all these different optimizations to very efficiently load my images, but gosh, I really have to write a lot of code in order to take advantage of all these different options. WiseCBCR was actually a particular case of this. In order to really get the best possible performance in your app, you had to write code that started out like this. And then you had this. And then you had this. So, point taken. It was really hard to use some of these if you really want to take advantage of performance. Well, in Windows 10, we have a new API, which is much simpler, and you still get all these advantages and optimizations, but they're built into this really simple API, and that's image source. How do you use an image source? Well, you call create image source from Wix, so you hand it your Wix bitmap source, and you can specify a few different parameters, things like loading options, specify whether or not you want the content immediately loaded into hardware or whether you want to dynamically pull it as your user views different parts of the image, for instance. Then when you want to render it, well, it's just an image, so you can use any of the existing image-based APIs. For instance, draw image or, say, image brush. Now, image sources have a number of advantages that you find with previous APIs that we had. For instance, we support arbitrarily large images. Even if your max texture size on the particular device is something much smaller than the image that you want to load, you can use image sources and we'll automatically stitch together it in all the appropriate ways. And since they're just images, you can easily integrate them into, say, printing, or you can apply effects to them. And they also have a number of other baked-in optimizations that we didn't even give you didn't have access to in previous versions of the OS. For instance, you can now have much more control over when content is paged into hardware memory. We also have much finer-grained locks. So if you're doing background loading of your images, it will play much nicer with whatever foreground animations you may have. Let's switch over to another topic, effects, and some of the optimizations that we've been adding here. First of all, what are effects? Well, in Direct2D, effects are a way of applying a graphical transformation to pixel data. We have a number of built-in effects, things like hue rotation and Gaussian blur that you can use. If you're familiar with Direct3D, you'll be aware of pixel shaders and vertex shaders and compute shaders. Effects are really layered on top of this. So a given effect may involve one or more of these shaders. Now you could use an effect and simply apply one effect to a bitmap. Direct2D makes that pretty easy. The real power of the D2D effect engine really comes into play, though, once you start combining multiple of these effects together. For instance, you might have a photo editor that took one bitmap and then applied a series of different graphical transformations to it. Contrast, exposure, blah, 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 and you end up getting a much nicer output, I mean. Now, Windows 8.1, we use a very straightforward procedure to render this content. You'd start off with that initial bitmap, then we'd apply the first effect, we'd render that into an intermediate, and then we'd apply the second effect, or we'd render that into an intermediate, so on and so forth. Now, we'd be a little bit clever. For instance, we wouldn't require you to use, we wouldn't internally use a different intermediate for each effect. We could do some optimizations there. But really, you ended up having to do a full 5 shader passes in this case in order to apply all those effects. In Windows 10, we have an improvement over this, which is that we now take a more global view of the effects. And so instead of applying each one sequentially, we'll look and see whether or not it's possible to combine multiple of these into a single shader. We can do this, generally speaking, if you are using a pixel shader, and if that pixel shader, for every output pixel, looks exactly one input pixel. This is pretty common. In fact, in this case, we've got 4 effects here that all start off being simple. This last guy here, the Sharpen Effect, is a little bit unusual. It actually requires multiple input pixels in order to get one output pixel. In this case, Direct2D is just going to give up and say, hey, you know what? I'm going to fall back to my old mechanism and render this using a second shader pass. For those of you who want to be really clever, you can actually move this, tweak this guy, move the Sharpen Effect to the beginning, and then you can actually combine this all into a single effect, a single shader pass. Let's actually take a look, see how this works in practice. Here, I'm actually taking a 10 megapixel image, and I'm applying those same effects that you saw on the previous slides. And this is using the old Windows 8.1 approach. And we're measuring the total amount of work that's being done on the GPU per frame. You can see in this case, it's between 60 and 70 milliseconds. So this is without the optimization. Now, when I turn it on, boom, it drops down to 40. So it's a nice little benefit that you can get with shader linking. Switch back here. So how do you use shader linking? Well, you get it essentially for free if you're using our built-in effects. You don't have to do anything at all. If you're one of our hardcore users or hardcore developers who's actually designing your own custom effects, well, we have some HLSL macros that help you along in the process. I've got a link to the slides link in the slides that you can check out later, see how to do that. Nonetheless, we think that it's a neat thing that you get for free most of the time. Before we change topics, one more thing on image effects. And that is, we've got a whole bunch new built-in effects. We actually have 17 of the most requested new effects. You can see these span a variety of different areas, particularly the photo area. So please do start incorporating these into your applications and play around with them and have fun. Finally, I'd like to talk to you about a couple of new primitives that we've added for Direct2D. Now, the first of these isn't actually specific to Direct2D. It's actually part of a wider Windows initiative. And I'm sure you guys have all heard about this by now. It's been in the keynotes and on a lot of the floors. And that's inking. Now, I gotta say, I'm a math guy. I absolutely love inking. It gives you just a much more natural way of being able to interact with the computer. I can enter in equations really beautifully. I can draw diagrams. It's just a really much more natural way than having to hunt and peck on a keyboard to use a mouse. The way that we encourage developers to use inking in Windows 10 is via the Direct Ink APIs, specifically the XAML inking canvas and the ink presenter. Now, under the covers, this is actually using a variety of Windows technologies in order to actually capture that content and render it onto the screen. Crucially, in far as the graphics go, that's all being done under the covers by Direct2D. Why do they do this? Well, Direct2D offers a number of advantages here. First of all, just like every primitive in Direct2D, this is a hardware-accelerated operation, which means that you're able to draw large amounts of ink in real time, even change it on the fly. This also helps reduce the latency of ink, which means that you get ink that sticks to your stylus as you're drawing. It feels much more like real ink. It's also vector content, which means that you get nice, crisp edges, and you can zoom in on it, and you get Beziers, so you get things that are always smooth. You don't get any sort of polygonalization. I've got a demonstration of this. Whoops. I apologize, this is my own handwriting, so it doesn't, it's not as legible as if an artist had done it. But this is all being rendered by Direct2D. And because it's done by Direct2D, it's all completely live. I can zoom in on it. Every frame here is vector graphics. It's all being done by with Beziers, which means that I can zoom in ultra close here. I'm still getting a nice, smooth B around here. And again, you can do really cool things, like you can say, hey, this is interesting. You know what? I think I want to write a little annotation here. do a little area under the curve magic here. And that all just zooms in with ink. I don't know about you, I just think that this is so cool. But it doesn't actually stop that. Yeah, please. I think the Direct Ink guys have done an amazing job with this stuff, too. Because this is vector content, you can really change it dynamically on the fly. You can even make my ink, my handwriting look better. You can make it a little bit calligraphic here. You can even change the orientation of the nib on the fly. And this happens to all your content. No matter how much is on the screen, you can just keep manipulating all this stuff on the fly. I just love that. That's inking. I really hope that you guys will start adding inking into your applications. If you want to know more, please do check out the Direct Ink talks. They happened earlier, but you can still find all the slides and the content online. One last feature that I'd like to talk to you about is gradients. Now, in Windows 8.1, Direct2D offered you basically two types of gradients. You had linear gradients, and you had radial gradients. Now these were kind of cool. I mean, you could do some nice simple lighting effects, or you could throw as many colors at this as you wanted. You could play around with the gradient stops, but they were still inherently limiting. You really didn't have any control over the shape of your gradient. You got either a line or you got an ellipse. Well, in Windows 10, we're exposing a new type of gradient, which is a gradient mesh. These are a much more flexible type of gradient. And unlike linear radial gradients, it's not a brush. It's a full-fledged primitive, which means that you can dynamically twist and control the shape. And when you do this, you're actually affecting how the gradient contours actually flow. Now, we didn't actually invent gradient meshes out of thin air. This is actually based on an industry standard concept known as a tensor patch. And you can find tensor patches today inside of things like the PDF reader or even the newly announced gradient meshes for SVG. I think it still hasn't been finalized, but it's going to be part of SVG 2. Now, the way that this works is a gradient mesh is composed of one or more gradient patches. And each patch is pretty straightforward. It starts off as a square, and you're able to specify the colors at the four corners of that square. And then if you're familiar with the way that Bezier is working with geometry and the control points there, well, instead of having 4 control points for a Bezier, you have 16 control points for a patch. And you can use these control points to twist and shape your gradient in whatever way that you want. In terms of code, you first specify your control points, and you specify your colors, and then you also have a little bit of metadata specifying how you want things anti-aliased. You pass that to create gradient mesh, which creates a resource, and then you just draw that gradient mesh. Let's take a look. Now, one of the things that is nice about gradient meshes is you can use them individually, but you can also use them, a whole bunch of them, and combine them into a larger piece of artwork. Now this looks, if you look at it really quickly, it looks almost like a photograph. It certainly doesn't look like 2D content. I mean, it's got some nice highlights and shades to it. But this is entirely composed of gradient meshes. In fact, it's got about 400 different patches in here. And because this is vector art, I can zoom in and out of it. It's all hardware accelerated, so you get nice, smooth zooming in. And it's all based on Beziers, so you get nice, smooth edges. So it's something that we think that you can add to your application. You can get a much more customization over the look of your application and get it to look more beautiful and, or the way that you want rather than what we're allowing. So I've gone through a number of different feature areas here and talked about a number of enhancements. If there's one thing, or if there's four things that I want you to take away from, it's this. In Windows 10, your DirectX app will be faster because you can take advantage of all the optimizations that we've added. It's going to be more maintainable because you need to write less code to get the same or better performance. It's going to be more consistent across devices because you don't have to worry about such things as what fonts are available on what device. And it's going to be more beautiful because you can take advantage of new primitives like gradient mesh. So again, I want to thank you all for coming. If you want to know more, I've got some resources up on the web, so please do check those out. And please evaluate this session. Thanks. And now it looks like we have some time for some Q&A, so if you guys have any questions, please. Oh, we have a couple of microphones up here if you want to use those so that they can be recorded. Sorry, the big list of image enhancements. All the new image effects that we have, the built-in effects. Can you talk to me offline and I can get you those slides?
Was the amount of this font stored on the phone, were those bitmaps or vectors?
That's vector content.
Okay. And will this work?
Oh, sorry, for those who didn't hear the question, are the fonts that are stored on the phone, are they bitmaps or vectors? Well, they're vector content, and so they can be sized at any size and they'll look crisp.
And do you work with fonts you import from third parties?
Yeah. So, sorry, the downloadable fonts are only the Microsoft fonts. And are you speaking with regards to the phone?
Anything.
So on the desktop, certainly you can use whatever font that you want, and you can install those fonts. I'm not actually the font expert, so to completely answer your question on the phone, I need to get in touch with you afterwards, and we can sync up. Any other questions? Well, thank you. Oh, go ahead, yes. Oh, can you please use the microphone so it's recorded?
So I see your shirt says mine goes to 12. Is Direct2D and DirectWrite on Windows 10 taking advantage of DirectX 12?
That is an excellent question. It seems like a really great fit. I mean, DirectX 12 is all about performance. Direct2D is all about performance. To answer your question, though, right now DirectX 12 is really focused on the AAA gaming market, and we want to make sure that that succeeds first before we spend resources on actually incorporating and moving our stuff over to DirectX 12. But it's definitely something that we're thinking about. Yes?
You said that the XAML applications would get the benefit of the downloadable fonts. Does that include WPF applications?
No. This is XAML technology as opposed to XAML. But another reason for you to switch over to the new Windows 10 hotness.
Are all the new features and APIs you have shown already available in the current Windows 10 preview?
Yes. Yes, please do download them. They're part of the SDK. You can use them right now. Great. Thank you all.